Hello, my dear mechanical champions. कैसे हैं सब लोग? What's up? Can you guys hear me? Myself, Chandrasekhar, welcoming you all once again to this beautiful series for thermal engineering. We are discussing the previous 5-year questions, gate questions from the thermal engineering. We have already taken 2 sessions already for thermal. I have completed the gate previous year question for 2019. I have completed the gate previous year question for 2020. Today we will be discussing about the questions from, what is going on? I don't know. I will be discussing today the questions from gate 2021. All right. So guys, those who are watching me live, please respond through the comment section if my audio and visual quality are fine or not. Am I properly audible and visible to everyone? क्या मेरी आवाज आ रही है आप लोगों को? Please respond quickly because we have long way to go. There are so many questions asked in 2021 set 1 and set 2. So we are supposed to complete all the questions within 1 hour. So quickly respond me through the comment section if I am audible and visible to all of you. मेरे को कुछ दिखाई नहीं दे रहा है आपके comments. Either you are not writing anything or I am not able to see your comments. So this is my quick introduction for those who are attending the session for the very first time. I am mechanical engineering graduate from IIT Delhi, having more than 10 years of teaching experience in the field of GATE, IES and PSUs. I have also cleared engineering services examination, worked in SAIL for a couple of years, and these are my favorite subjects of mechanical engineering, right? And you can connect with me through the mail ID if you have anything to discuss, and it is important if you become part of my Telegram group. There are so many students, more than 1500 students are already part of my Telegram group. So do join me on the Telegram. Once you become the part of my Telegram group, you will be able to get the notification for various exams, PDF notes, session updates, and doubt clarification will also be going to happen on my Telegram channel. That is Mechanical by Chandrasekhar, and the link is also mentioned at the bottom of the screen, right? Am I audible and visible to you or not? Nobody is responding. Why? You are supposed to solve the questions. And if you have any doubt, you can raise your concern through the comment section. And tonight at 7:30 p.m. there will be a free workshop. Abhinav Negi sir le rahe hain us workshop ko. He will be going to discuss the most important factors which will be required for you if you want to become the GATE 2024 topper. You should register yourself through the link mentioned in the description box, right? So please do share this information to all your friends, all your colleagues who are going to appear for GATE 2024 exam. This session, this workshop is going to be very beneficial to channelize your energy in the right direction to crack the GATE 2024 exam, right? So this session which I am taking right away is the part of last 5-year GATE question series for civil and mechanical engineers. The series is already running successfully. Lot of love we are getting from the students for this series. So today we are going to discuss the thermal engineering previous year question for GATE 2021, right? This is the entire schedule for mechanical branch. We are here. It is the 3rd session of thermal. Let me hide myself. We are on the 3rd session of thermal, not 4th. We are here, 3rd session. Tomorrow again at 4 p.m. there will be one more session which we will cover GATE 2022 and 2023 BYJU'S. All right. Then mechanics will be done on the next day, taken by Suraj sir, and then production engineering, and again after that I will be coming back for the heat transfer. I know you are not able to see it properly, but I have already given you the idea. So subscribe our BYJU'S YouTube channel, then you will get the notification of these sessions. Shall we start? Shall we start the session? Let us start with the first question. Very basic, simple and theoretical, conceptual question. In which of the following pairs of cycles both cycles have at least one isothermal process? The various cycles are given in the options. Which pair of cycles is having at least one isothermal process? What is Bell-Coleman cycle? It is the reverse Brayton cycle. It is called as reverse Brayton cycle, which is used in refrigeration. Or we can call it as reverse Joule cycle, which consists of two isentropic process and two constant pressure process. There is no isothermal. Vapor compression cycle, one isentropic compression, and the another will be isenthalpic. There is no isothermal. Diesel and Otto cycle, they are having the isentropic process only. Isentropic. Otto cycle, two isentropic and two constant volume. Diesel cycle, two isentropic, one isobaric and one isochoric. All right. Carnot cycle and the Stirling cycle are having, Carnot cycle consists of two isothermal processes and two reversible adiabatic processes. Stirling cycle consists of two isothermal and two constant volume process. Brayton cycle and Rankine cycle consisting of two adiabatic or isentropic along with two isobaric constant pressure processes. All right. So option C will be the correct answer for the given question. First question asked in GATE 2021. All right. Then next question, question number 2 on your screen. In the vicinity of the triple point. What is the triple point? Triple point is the temperature and pressure condition where all the three phases of a pure substance coexist in equilibrium. What is triple point? Triple point is the temperature and pressure condition at which all the three phases of a pure substance simultaneously exist in thermal equilibrium. All right. So the equation of liquid vapor boundary in the PT phase diagram for ammonia is given by this expression. In the liquid vapor boundary, it is given by this expression, and the solid vapor boundary, it is given by this expression. Now, because the temperature and pressure condition will be same, it is a single point where liquid, vapor and solid coexist in thermodynamic equilibrium. That is called as triple point. So we can say P will be same as this P. So if we equate these two equations at the triple point, can we say ln of P, which is equal to 24.38 minus 3063 upon T, should be equal to 27.92 minus 3754 by T. Can you find out the value of T here by equating these two? Can you get the value of T? Yes, every one of you. Equate both the equations, you will get the value of T. Will you be able to find out? So we can say 3754 minus, we can write 3754 minus, just hold on, 3754 minus 3063 upon T is equal to, it will be 27.92 minus 24.38. So what is the value of T? T is equal to 3754 minus 3063 divided by 27.92 minus 24.38. So what is the temperature? Are you guys getting it as 195.2 Kelvin? It is around 195.2 Kelvin. Are you guys getting it or not? This is question number 2. Are you getting 195.2 or not? Is this clear? Let us move to the next one. The question can either be solved by direct formula or you can derive the formula. If you know how to apply first law of thermodynamics to unsteady state process, unsteady flow process. Do you know how to apply the first law of thermodynamics to the unsteady flow process? If Q is equal to W is equal to 0, a rigid insulated tank. So rigid tank means V is equal to 0 or W is equal to 0. PdV, there is no work done, and insulated means Q is equal to 0. If Q and W is equal to 0, then the final temperature of the air inside the tank T2 is equal to gamma times of Ti. How many of you remember this formula? How many of you remember this formula? T2 is equal to gamma times Ti. Ti is the temperature in the supply line. Ti is the temperature in the supply line. So gamma is equal to Cp is 1.005 upon Cv is 0.718 into Ti. What is temperature of the supply line? That is 400. That will give you the answer. That is T2. Isn't it? Can you find me the answer? Are you getting 599.8? Are you guys getting 599.8 Kelvin or not? How you are getting this relationship? Let me discuss that. There is a tank like this. There is a wall and this is the supply line. This is the wall. So it is rigid and insulated, let us say. Let us not take it as rigid and insulated. So it is, so if we apply the mass conservation, then we can say dm by dt in control volume is equal to mass entering minus mass leaving, mass flow rate entering minus mass flow rate leaving. That is change in mass in the control volume, isn't it? That is the mass conservation equation. And the process is 1 to 2. So we can say change in mass in control volume. Can we write Mi minus Me, mass entering minus mass leaving, is equal to M2 minus M1 in the control volume, change in mass in control volume. If the system is initially evacuated, this is our system. If it is initially empty, M1 will be equal to 0 and there is no mass leaving from the system. There is no mass leaving from the system. Me is equal to 0. This. So what we get is, what we are getting is Mi is equal to M2. That is one condition. And now if we apply the energy equation, mostly the question will be asked from the mass conservation equation and energy conservation equation. If we write the energy equation, then we can say dE by dt in the control volume is equal to energy entering in the control volume minus energy leaving from the control volume per unit time, or change in energy. Or if I don't write per unit time, then also it will work. For an example, if I like this, change in mass in control volume is equal to Mi minus Me. Similarly, change in energy in the control volume, is equal to energy entering minus energy leaving. So energy entering minus energy leaving will be the heat is added to the system Q minus work done by the system. This is how the energy is entering and leaving, and then energy entering through this supply pipeline plus Mi into Hi minus energy leaving Me into He along with the mass, energy entering and energy leaving, is equal to, we can write it as M2 into U2 minus M1 into U1, isn't it? Why? If we assume change in potential energy and change in kinetic energy to be 0. There is no change in potential energy, there is no change in kinetic energy. So this will be the expression. And because Me is equal to 0 and M1 is equal to 0, so we can say Q minus W plus Mi into Hi is equal to M2 into UT, specific internal energy. So if the question says Q is equal to W is equal to 0, if Q is equal to W is equal to 0, that is given. The system is thermally insulated, there is no work transfer. So we can say Mi into Hi is equal to Mi into Hi is equal to M2 into U2. So Mi is equal to M2, that is what we have already discussed. Mi is equal to M2. So these two will get cancelled out. So what is Hi? Cp into Ti is equal to what is U2? That is Cv into T2. So from here T2 is equal to Cp by Cv into Ti. That is how this is the final temperature we can obtain. Final temperature we can obtain. Ti is the temperature of the supply pipeline. Right? The next question. Sometimes they modify the question. Sometimes what do they do is they give some heat transfer, they give some work transfer. If that is the case, then this expression will not be valid. So you should always remember, if you remember any formula, if you memorize any formula, you should always remember the condition in which a particular formula is applicable. All right. The next one, question number 4. Superheated steam at 1500 kilopascal has a specific volume of this. This is the pressure, specific volume V. The unit, if you will see, it is not meter cube per kg, it is meter cube per kilomole, and compressibility factor Z is equal to 0.95. What is the compressibility factor? We can say PV is equal to Z into R into T. So Z is equal to PV by RT. That is called as compressibility factor. Z is called as compressibility factor. So because V is given per unit kilomole, so R should be taken in terms of kilomole, that is R bar. And we need to find out the temperature of the steam in degrees Celsius. If you do the calculation, if you put the value, so Z is equal to 0.95 is equal to pressure is 1500 kilopascal into specific volume 2.75 meter cube per kilomole and divide by 8.314 kilojoule per kilomole Kelvin into T. If you find out the value of T, which will be in Kelvin, the temperature in Kelvin will come out to be 522 Kelvin. Please check and do let me know if you are getting this temperature or not. 1500 into 2.75 divide by 8.314 divide by 0.95. It is 522.26 minus 273 minus 273 will give you the temperature in degrees Celsius. It will be around 249.26. The temperature in Kelvin will be 249.26. Okay, it is already there. Na? B option is correct. Option B. 522 will be in Kelvin. The temperature is 522 in Kelvin. So please do not forget to like and share this session, guys. Let us move to the next question. Question number 5. Read the question. Consider a steam power plant operating on an ideal reheat Rankine cycle. Rankine cycle, there is a phase change. The work input to the pump is 20 kilojoule per kg. WP is equal to 20 kilojoule per kg. That is the specific work. The work output from the high pressure turbine is WT1 750 kilojoule per kg, and the work output from the low pressure turbine, that is WT2, is 1500 kilojoule per kg. The thermal efficiency of the cycle is 50%. The enthalpy of saturated liquid and saturated vapor at the condenser pressure. What is at condenser pressure? At the condenser pressure, HF is enthalpy at saturated liquid is 200 kilojoule per kg and saturated vapor is Hg is 2600 kilojoule per kg respectively. The quality of steam, we need to find the quality of steam at the exit of low pressure turbine. Quality or the dryness fraction of the steam to be calculated. We need to calculate the dryness fraction. All right. So if I draw the diagram, if I draw the figure, temperature versus entropy. This is high pressure turbine, expansion in high pressure turbine. Then there is a reheating. If they are talking about the dryness fraction, it means it is inside. This is how, this is the pump. This is how the figure will be drawn. This is 0.1, this is 2, this is reheat, this is 0.4. We need to find out 5 and 6. We need to find out X4. X4. Now, can we say what is W net from here? What is the network output? That is equal to WT1 plus WT2 minus WP. That is the network output. How much is that? 1500 plus 750 minus 20. 1500 plus 730. 1500 plus 730. 2230, isn't it? Isn't it 2230? kilojoule per kg. And can we find out heat supplied? This is Q1, this is heat rejected Q2. So the thermal efficiency is equal to W net upon Q1, or we can write it as W net upon Q2 plus W net. So the thermal efficiency is 0.5, 50% is equal to 2230 upon Q2 plus 2230. Can you find out the value of Q2? What is the value of Q2? Are you getting it at 2250? Please check and do let me know how much is the value you are getting for Q2. What is the value of Q2 you are getting? Or that is H2 actually. We can call it as H2. Not H2. It is H4 minus H4 minus H5. Q2 is equal to H4 minus H5. So this is equal to H4 minus H5. And what is H5? That is equal to H4 minus what is H5? H is saturated liquid 200. So H4 will be equal to Q2 plus 200. So that is 2450 kilojoule per kg. H4 will be equal to 2450 kilojoule per kg. Isn't it? Once we get H4, that is equal to HF plus X4 into HFG. This is 2450. What is HF? That is 200 plus X4 is the unknown. What is HFG? HFG is HG minus HF. What is HG? 2600 minus 200. 2600 minus 200. Can you find out the value of X4? That is the dryness fraction at turbine exit. That will be the dryness fraction at the exit of the turbine. Can you solve it? What is the value of X4? What is the value of X4? Is this 0.9375? Are you guys getting 0.9375 or not? That will be the answer. I hope you have understood it. 0.9375 or 93.75. In terms of percentage, it will be 93.75. In terms of percent, it will be 93.75. Alright, so there is an important announcement. We have started another course for ISRO 2023 on the students' demand, that is the practice course. And the course had already been started from yesterday. So every alternate day we are having the practice for different subjects for ISRO 2023. So yesterday Dheeraj sir had already taken a session. Tomorrow I will be taking a session, not at 11, the timing will be 12. At 12. Tomorrow I will be taking in this session at 12 noon for the fluid mechanics. 24 the most important questions will be discussed tomorrow at 12. And then on 16th, 17th is Saturday, we are discussing the ISRO PYQs. Every Saturday we are discussing one single paper, the complete paper for ISRO. And again 19, 21st, 23, this is the entire schedule. And after this there is a complete schedule. I have not taken the screenshot of the entire schedule. After 24th we will share the remaining part of this. The next question is from the psychrometry. This is question number 8. The relative humidity of ambient air or humidity ratio of ambient air is 50%. Relative humidity RH, that is equal to phi. Phi is given as 50%, 0.5 at 300 Kelvin, that is the temperature. With a partial pressure of water vapor equal to PV, the saturation pressure of water is P saturation. The correct relationship for water air mixture is, it is very simple. Phi is equal to partial pressure of vapor divided by the saturation pressure. So the ratio is PV is equal to 0.5 P saturation. B is the answer. 0.5 into P saturation. The next question is beautiful. It is again from the mass conservation and energy conservation. The question is based on mass and energy conservation. An air conditioning system provides a continuous flow of air to a room using an intake duct and an exit duct. This is the exit duct. This is the intake duct, as shown in the figure. To maintain the quality of the indoor air, the intake duct supplies a mixture of fresh air with a cold air stream. Fresh air and cold stream. They are mixed in the mixing chamber. They are mixed in an insulated mixing chamber located upstream of the intake duct. Cold air enters the mixing chamber at these conditions with a volume flow rate of 1.25 during steady state operation. Fresh air enters the mixing chamber at 34 degrees Celsius, 105 kilopascal. The mass flow rate of the fresh air is 1.6 times the mass flow rate of cold air stream, right? Air leaves the room through the exit duct at 24 degrees Celsius. This is 24 degrees Celsius. Assuming the air behaves as an ideal gas, there is no heat transfer outside the system because the system is insulated. So whatever the heat entering into the room will be rising the temperature of the room. Cp of the air is 1.005. R is given. The rate of heat gain by the air from the room is, so Q is equal to mc delta T will be the will give you the answer. Isn't it? Now, look, if I draw the diagram like this, this is the mixing chamber. This is our mixing chamber. And here it is the cold air. Here it is the fresh air. So cold air is entering at 105 kilopascal and it is entering at the temperature at 5 degrees Celsius and it is entering at a volume, a specific volume of 1.25 meter cube per kg. And the fresh air is entering at a pressure of 105 kilopascal and at a temperature of 34 degrees Celsius. So we need to find out the temperature. This is, let us say, 1. This is, let us say, 2. We need to find out the temperature T3. First of all, let us try to find out the temperature T3. First of all, apply the mass conservation. Can we find out m.1? Can we find out m.1? Because it is an ideal gas. So we can say PV is equal to mRT, isn't it? So PV dot, it is V dot actually, meter cube per second. It is not the specific volume, it is meter cube per second. Volume flow rate, it is volume flow rate, meter cube per second. So can you say from the ideal gas equation, can we use this? So m.1 is equal to P1 into V1 dot upon R into T1. Can you put the values? P1 is 105 into V1 is 1.25 upon R is equal to 0.287 into temperature T is 5 degrees Celsius, means 273 plus 5, 278. Isn't it? What is the value of m.1? m.1 will come out to be 1.645. Isn't it? Once we get m.1, m.2 is 1.6 times of m.1. m.2 is 1.6 times of m.1. That will be 2.632 kg per second. First, and m.3 from the mass equation or mass conservation. If we apply the mass conservation, using the mass conservation, can we say m.3 is equal to m.1 plus m.2? That will come out to be, add both of them, 4.277 kg per second. That is m.3. Now if we apply the energy equation, what is energy equation says? m1 h1 plus m2 into h2 is equal to m3 into h3. Or if we write H is equal to Cp into T, H is equal to Cp into T. So can we write it as M1 into T1 plus M2 into T2 is equal to M3 into T3. Can we find out the value of T3 from here? Can we find out the value of M1 into T1? What is M1? M1 is given as, calculated as 1.645 into what is the temperature? 5 degrees Celsius plus M2, that is 2.632. 2.632 into T2, that is 34, is equal to M3, that is equal to 4.277 into T3. We will get the temperature T3. T3 will come out to be, we can use the temperature in degrees Celsius in the energy conservation equation. So T3 will come out to be, what is the value of T3? Are you getting 22.846 degrees Celsius? This is the value of T3 by using the energy conservation. If you use the energy conservation, right? Now, from the point 3, there is a room and there is point 4, let us say. What is the value of T4? The The outside temperature is given as 24 degrees Celsius. This is 24 degrees Celsius and T3 is this. So can we say it is M3 which is entering? So can we say the question is to find out the rate of heat gain, that is Q gain, the rate of heat gain, Q gain is equal to M3 into Cp into T4 minus T3. How you are getting rate of heat gain? The rate of heat gain by the air from the room. Yes, the rate of heat gain by the air from the room is equal to T4 minus T3. That is the rate of heat gain. So M dot 3 is already calculated 4.277 into Cp is, the answer should be in kilowatt. So Cp is equal to 1.005 and 24 minus 22.846 will give you the answer. So are you guys getting it as 4.96 kilowatt or not? 4.96 kilowatt. That is how the question will be solved. 4.96 kilowatt. Right? The next question is again about the mass and energy conservation. Consider the open feed water heater shown in the figure. This is the open feed water heater. Specific enthalpy of steam at location 2 is this H2. Specific enthalpy of water at location 5, that is H5. Specific enthalpy of saturated water at location 6, that is H6. If the mass flow rate of water entering the open feed water heater, that is at location 5, is 100 kg, this is 100 kg per second, then the mass flow rate of steam at the location 2 is, that is M dot 2 is how much? That is the question. So can we say, first of all, from the energy mass equation, can we say from the mass conservation for the open feed water heater, for feed water heater, if we apply the mass conservation, can we say M dot 2 plus M dot 5 is equal to M dot 6? So M dot 5 is already given, that is 100. So M dot 6 is equal to M dot 2 plus 100, isn't it? And now if we apply the energy conservation equation, can we say M dot 2 H2 plus M dot 5 H5 is equal to M dot 6 H6? The question is to find out. So M dot 2 H2 is given as 2624. 2624. M dot 5 is 100 into H5 is given as 226.7 is equal to M dot 6 is M dot 2 plus 100 into H6. What is H6? H6 is 708.6. So if you solve, the only unknown is M dot 2. If you solve it, you will get the answer. The only unknown is M dot 2. Can you do the calculation for me and get me the answer? And please check and do let me know if you are getting 25.16 kg per second or not. In 2021, most of the questions were asked based on mass conservation, energy conservation and entropy balance. This is the answer to the next question. The psychrometry question from the psychrometry is very simple. Ambient pressure, temperature and relative humidity at a location are, the pressure is P, PT total pressure or ambient pressure, temperature is 300 Kelvin and phi is equal to 60%. The saturation pressure of water at 300 Kelvin, vapor pressure or we can call it as saturation pressure, is 3.6 kilopascal. The specific humidity of ambient air is omega is equal to 0.622 into PV upon PT minus PV. That is the question. That is the formula that will give you the answer in kilogram vapor per kg of dry air. That is the unit. But the question is wanting the answer in gram per kg of dry air. It is dry air. So first of all, we need to find out PT is given. We need to find out PV. So phi is equal to 0.6 is equal to PV by P saturation, isn't it? So PV is equal to 0.6 into 3.6. So first of all, find out the value of PV. What is the value of PV? 0.6 into 3.6. 2.16, isn't it? It will be 2.16. 2.16 kilopascal. Put the values. So omega will be equal to 0.622 into PV, that is 2.16, upon total pressure, that is 101 minus 2.16. 2.16 multiplied by 1000. Do not forget to multiply by 1000 to get the final answer in gram per kg of dry air. If you do the calculation, if you will do the calculation correctly, you will end up getting the answer as 13.59. Please do check. 13.59 gram per kg dry air. It is simply the formula based. These are the two formula which are very, very important in psychrometry. Right? And from tomorrow, we will be starting a beautiful series. One part of the series is running on YouTube and the another part will be running on app. So it is a combination of YouTube and app. So if you have not downloaded the YouTube, the BYJU'S app yet, please do download it. And tomorrow there will be a session at 5 p.m. taken by Abhinav Negi sir for strength of materials, and day after tomorrow on today's 14, today's 13, on 15th of June, I will be taking this session for fluid mechanics. That is the Bernoulli equation. So do join these sessions and share this information to all your friends. There are 4 sessions, and the best part is the toppers, top 5 students will get the surprise gift hamper for this. Let us move to the next one. This is our question number 10. Question number 10. There are total 12 questions from GATE 2021. Consider an ideal vapor compression refrigerant cycle working on R134A refrigerant. The COP of the cycle is, so it is not about VC cycle as such. It is just about the refrigeration cycle. This is, let us say, Q2, this is Q1, that is work input, and this is the desired effect. For refrigerator, it will be the desired output or desired effect or cold storage space. So COP is given by, COP is 10, which is equal to Q2 by W, isn't it? W in, and the refrigeration capacity, that is Q2, is given as 150 kilojoule per kg. Refrigeration capacity or refrigeration effect is Q2, the amount of heat which is extracted from the storage space, that is called as refrigeration capacity or effect, refrigeration effect. So Q2, so we can find out, so what is that? We can find out W. Q2 is equal to 150 by W. So W is equal to 150 by 10, that is equal to, W is equal to 15 kilojoule per kg, right? 15 kilojoule per kg. The heat rejected by the refrigerant, the question is to find out Q1, and according to first law of thermodynamics for the system, Q1 is equal to W plus Q2. So 15 plus 150, that is 165 kilojoule per kg will be answer for this one. This is from the, this is for the second law of thermodynamics. Let us move to the next question. Question number 11. A rigid tank, constant volume of 50 meter cube. This is the volume, contains a pure substance as a saturated liquid vapor mixture. So this is the volume of the mixture. At 400 kilopascal, that is the pressure of the mixture. Of the total mass of the mixture, 20% mass is liquid and 80% mass is vapor. Properties at 400 kilopascal are: saturation temperature is given, and specific volume of saturated liquid and specific volume of saturated vapor at this saturation temperature is given. The total mass of the liquid vapor mixture in the tank is. So the total mass of the mixture will be equal to volume of the mixture upon specific volume of the mixture. Volume of the mixture we all know. Now we need to find out the specific volume of the mixture, and we can say specific volume of the mixture is equal to Vf plus X into Vg minus Vf. That is the specific volume of the mixture. We need to find out the dryness fraction because Vf and Vg are given. So if we can find out the dryness fraction, what is the dryness fraction? So first of all, let us find out the dryness fraction, that is mass of vapor upon mass of liquid plus mass of vapor. That is the definition of dryness fraction. What is the mass of vapor? 80% is the mass of vapor, 0.8, and 0.2 plus 0.8. So 0.8 will be the dryness fraction. So if we get the value of dryness fraction, we can find out the specific volume of mixture, that is Vf 0.001084 plus dryness fraction 0.8, then Vg minus Vf 0.46242 minus 0.001084. If you calculate this, then we will get the specific volume of the mixture. The specific volume of the mixture will come out to be 0.3701. 0.3701 meter cube per kg. That is the specific volume, and the total volume by specific volume of the mixture. Put in equation number 1, then we will get mass of the mixture is 50 meter cube divided by 0.3701. 0.3701. What is the answer? Are you getting it as 135.08 kg is the mass of the mixture. And one more question, but before that, I am having the series running on BYJU'S app also. There is another series which is running on BYJU'S app, ISRO previous year thermal questions. So today at 7 p.m. I will be meeting again on the BYJU'S app for practicing or for discussing the ISRO 2015 to 2017 PYQs. All right. So this is my entire schedule on the app free live classes. The last question, very, very beautiful. An adiabatic vortex tube shown in the figure given below is supplied with 5 kg of air inlet at 500 kilopascal and 300 Kelvin. High pressure air is supplied. Two separate streams of air are leaving the device from outlets 2 and 3. Hot air leaves the device at the rate of 3 kg per second. 3 kg per second from the outlet 2 at 100 kilopascal and 340 Kelvin. While 2 kg of, let me write here, 100 kilopascal and 340 Kelvin. While 2 kg per second, 2 kilogram per second of cold air stream is leaving the device from the outlet 3 at 100 kilopascal and 240 Kelvin. Consider constant specific heats of air at 1005 joule per kg Kelvin and gas constant is 287 joule per kg Kelvin. It is not joule kg per Kelvin. It is joule per kg Kelvin. It is joule per kg Kelvin. Kg should be here. All right. There is no work transfer across the boundary of the device. The rate of entropy generation in kilowatt per Kelvin is. You need to find out. So at point 1, 500 kilopascal, it is 5 kg per second and it is at 300 Kelvin. These are at point 1. These are the parameter at point 2, and these are the parameters at 3. So we need to find out the rate of entropy generation. Now, if you, this is from the entropy balance. Beautiful question. Do you know about entropy balance? Others, there is no guarantee. Nobody can take the guarantee whether you will be able to clear the examination except you. You are the only one who can take the guarantee. If you are doing the hard work without any fail, without any, or with your full dedication, then the chances are there that you will be able to crack. So from the concept of entropy balance, can we say the entropy balance, can we say entropy change for a system is equal to entropy transfer plus entropy generation. So entropy change for any system is equal to entropy transfer. This is very, very important. Try to understand this. The entropy change in a system is because of the entropy transfer, similar to energy transfer. But along with that, there is an entropy generation. If we talk about energy balance, do you remember about energy balance? If we talk about, let me write here, energy balance. If we talk about energy balance, then we can only say energy change is equal to energy transfer. Energy change is only due to energy transfer, because energy can neither be created nor be destroyed, is equal to energy transfer. But if we talk about the entropy, entropy can be generated. Yes, others, at least you will understand with these. It is not about the question, it is about the understanding the concept. If your concepts are clear regarding these questions, then it means you will be able to correct the similar type of question. So the questions are not important. The concept which are attached or which are related to these questions are important. The question will be framed from these concepts only. Either from the first law of thermodynamics, second law of thermodynamics, entropy balance equation. These are the important areas from where questions are asked. So that is why the previous year questions are important, because they give you an idea what are the topics from where the questions are normally framed. These are the important topics, right? So entropy transfer takes place due to heat transfer and due to mass transfer. Work, along with the work transfer, there is no entropy transfer. It is due to heat transfer as well as due to mass transfer. Along with the mass transfer, there is an entropy transfer, and entropy generation will take place due to internal irreversibility. When there is internal irreversibility, due to internal irreversibility. So if we write per unit time, if we write this expression per unit time, then can we say, that ds by dt in the control volume or the system is equal to, can we write it as entropy, the heat transfer, entropy transfer due to heat transfer. This is entropy transfer due to heat transfer plus m I into into Si. Si minus m dot E into Se, that is due to mass transfer, and this is due to heat transfer, plus entropy generation. So it is per unit time. This is per unit time. The unit is watt per Kelvin or kilowatt per Kelvin. This is the expression. So if it is steady flow, for a steady flow, properties do not change with time. For a steady flow, properties do not change with time. Do you understand? So ds by dt in the control volume will be 0. Properties do not change with time. So this term will become 0. And the question also says The question is also saying that it is adiabatic vortex, there is no heat transfer. So adiabatic, if it is adiabatic, it is an adiabatic device. So Q will be equal to 0. So the expression will become, so our expression will become m dot I Si minus m dot E Se plus S dot generation is equal to 0, or from here we can say S dot generation. This is the entropy generation, m dot E Se minus m dot I Si. Are you getting it? And entry is 0.1, I is 0.1, entry is 0.1, 1 is entry I, and exit is 2 and 3. E are the point 2 and 3. 2 and 3. So can we say exit are 2 and 3? So can we write entropy generation is equal to m dot 2 S2 plus m dot 3 S3 minus m dot 1 S1, isn't it? Can we write this? And from the mass equation, mass conservation, from the mass conservation, can we say m dot 1 is equal to m dot 2 plus m dot 3? Do you agree or not? So we can write it as S dot generation is equal to m dot 2 S2 plus m dot 3 S3 minus m dot 1 can be written as m dot 2. So minus m dot 2 S1 minus m dot 2, sorry, m dot 3 S1. Just a second. So it will be m dot 3 S1. Are you getting it? So can we write it as m dot 2 S2 minus S1 plus m dot 3 S3 minus S1? Isn't it? That is S dot generation. Isn't it? Are you getting it? And because it is an ideal gas, so for an ideal gas, delta S is Cp ln of T2 by T1 minus R ln of P2 by P1. Put the values. So if you put the values, then m dot 2, what is the value of m dot 2? So S dot generation is equal to, let me write here. So if we write S dot generation is equal to m dot 2, the value of m dot 2 is 3 into Cp 1. We want in kilowatt, so 1.005 into ln of, we are writing S2 minus S1. So ln of T2 by T1, it is 340 Kelvin and it is 300 Kelvin, isn't it? So ln of 340 by 300 minus R 0.287 into ln of P2 by P1. P2 is 100 kilopascal, this is 3 kg per second, and P1 is 500 kilopascal, so it is 100 by 500. This is one expression, plus then we will write m dot 3, this is 2 kg per second, so m dot 3 is 2. Then 1.005 ln of P3 by P1. What is P3? P3 is 240. Sorry, 240 Kelvin. Ln of T3 by T1, 240 by 300 minus R, that is 0.287 into ln of P3 by P1. What is P3? P3 is equal to 100 kilopascal. So it will be again 100 by 500. If you will solve this, then S dot generation will be obtained. The first term will be 1.76. You must get 1.76 plus the second term will be 0.47. So the final answer will be 2.23 kilowatt per Kelvin. 2.23 kilowatt per Kelvin will be the correct answer. I hope you understood this. Is 2.23 kilowatt per Kelvin. All right. So that is all for this session. Tomorrow again at 4 p.m. I will be discussing the questions from 2022 to 2023 GATE PYQ for thermal. All right. So that completes the session. If you have not joined me on the Telegram, please do join me and share this information to all your friends, and do not forget to like and share the session. All right. So there are other series which are running Super Saturday. Also, you can be part of these sessions, and to improve your GATE preparation, you just go through the description box. There are important links mentioned. All right. So that is all from my side, guys. Thank you very much. Take care. Jai Hind and see you tomorrow.